So let's go ahead and do another partially grouted wall problem, this time not knowing as much information, so we have to design it. It's a 10-inch CMU this time instead of 8-inch, 20-foot high, and then it has a lateral wind force of 32 pounds per square foot, right? So if I've got my wall here, I've got this wind force, and I'm just showing one dimension, it goes on into the page because it's pounds per square foot. We're going to assume a placement of the reinforcing steel at every 4 feet and 2000 psi masonry strength, yield strength of the steel. It's the normal stuff. They gave us D, but D is just the thickness of the 10-inch wall divided by 2, and if you can carry more digits if you want out on this. I'm not sure why they gave us what to assume quite to that detail. We know these things, but that's fine. All right, so let's go ahead and run through this problem. Okay, so I'm going to go ahead and just transfer D over here so I remember what it is, 4.8125 inches. I need to find the demand on this thing. Moment equals WL squared over 8. And the load case that we've got to use for wind includes a 0.6 times the 32 pounds per linear foot per foot of wall, right? So I don't have pounds per square foot because this is per foot of wall. All right, so moment equals 0.6, 32. The wall is 20 foot tall, squared over 8, and I get 960 pound-feet per foot of wall. All right, we actually are going to be looking at a section that is 4 foot because we've got reinforcement every 4 foot. So let's just transfer this into per 4 foot of wall for purposes of treating this like individual kind of beams, multiply by 4 feet. And now I have 3840 pound-feet per foot of wall, per 4 foot of wall. Okay, so that's going to be my beam section. I'm going to go ahead and start out by assuming that this is not a T section, so I'm going to assume that KD is less than the thickness of the flange. At that point, let's go ahead, whichever, if it's over or under reinforced, M is still KF times BD squared. Let me just check something here. Yep, okay, so KF then would be our 38, would be our 3840 pound feet times, gosh darn it, pound feet times 12 inches per foot for a unit conversion. Per 4 foot of wall is 48 inches, and my D value was 4.8125 inches squared. So I get a KF of 41.5, and so we know what to do from here, right? We go to the table that matches with the right concrete strength, and I can either interpolate between the two table values or I can go to the chart. And you can pause the video and go do that. Make sure you get the same basic thing, but from the chart or table, I get a rho value of 0.001385. That's if I go through the full interpolation from the table instead of the chart. I can't get that many significant figures if I go to the chart. That's fine. AS, you'll see it's not that big a deal either way. AS required is then rho BD. So I'm going to take that rho, and again, I could use less figures here because I'm still going to have to match this to a bar. So rho BD, 8, 1, 8125 inches. And I get an AS required of 0.32 inches squared. All right, I could probably get that down to 0.31, but there's no real sense in that. Technically, that wouldn't pass, and all this stuff has a little bit of leeway in it. I'm going to go ahead and just bump this up and use a number 6 bar, which we know is 0.44 inches squared. So as I said, because of the wiggle room here, it's really not going to matter. I'm providing plenty of reinforcement here. I could go in with a number 5 bar, kind of redo the calculations, maybe not use the chart and get a little more refined, but it's a number 5 or a number 6 bar per 4 feet. It's not going to break the bank. All right, so check the KD less than the thickness of the flange. I get an N value. They gave us an N value, so I actually don't have to check it, but N is the modular ratio, and I'm going to get 16.1 for that. Now let's check the actual row is going to be 0.44 over 48 times 4.8125. Sorry, I'm at the bottom of the page here. And I'll get an actual row with the steel I've provided of 0.0019. It's, higher than that, which is fine. So that's actually my design row. If I go in, I can go out and calculate this like a normal problem now, but let's check our assumption of KD less than TF. So I need K equals the square root of N row squared plus 2 times N row minus N, or minus, yeah, N row, I think. And K equals 0.22. So KD equals 1.05 inches, which is less than 1.25 inches. And so it is not a T-beam, and the rectangular stress block I used is fine. All right, so now I could go in, so basically we're pretty much done here, right? So we know that it's number 6s at 4 feet. So that's our solution, is number 6s at 4 feet, okay? But technically I should go back and check, but we know it's okay because I went up a bar size, so I've got plenty of steel. In masonry, it can be over or under reinforced, and at no time did we make that assumption because we did this all off the charts with KF, going to the smaller value on the chart, so we took that under account. And I checked my location of my neutral axis. So for an exercise, you go in and find the actual capacity and everything, because you'd want that anyway in your final calcs. So check with the number 6s at 4 and see how much over capacity you are, but it doesn't matter a whole lot because, again, number 5s at 4 and number 6s at 4 is not a huge difference. So if I wanted to check those, I find a key at KF, and from my row, go in the tables, and I get a capacity, right? So we'll wrap that one up. But not so much different when you have to do the design problem. With all these problems, it's basically you know the equations, you know what you have, and then you backtrack to find the thing that's missing. Just making sure, and this is just engineering design in general, when you make an assumption, you could put a star by it or something, or underline it, and make sure you remember I made that assumption, and then to check that assumption. So our assumption that we made in this is right here, right? And as long as I check that, then I'm good to go. All right. That's all there is to. So basically, at this point, we've done our both fully graded, partially graded. We've done beam sections. We've done wall sections. Okay, with this type of load on them. So that is a big chunk of what you'll actually do for some of the masonry design, and then we'll go ahead and go into the next section.